The journey of wood to paper. Paper, the ubiquitous companion of our daily lives, undergoes a fascinating transformation before reaching your hands. Let's delve into the intricate process of papermaking from wood in a factory. From forest to paper. The relationship between tree cutting and papermaking is complex, with both environmental concerns and sustainable practices to consider. While paper requires trees, modern paper production relies heavily on managed forests, where trees are planted and harvested in a controlled way. Still, deforestation remains a concern, with estimates suggesting over 2 million trees cut down daily for paper. The journey begins with logs arriving at the mill. Debarking. To remove bark, logs are sent through a rotating drum with teeth or knives. This separates the bark from the wood, preserving the valuable cellulose fibers within. Wood chipping for paper, transforming trees into pulp. The wood chipping process is the crucial first step in transforming trees into paper. It involves breaking down logs into smaller, uniform pieces called chips, preparing them for the pulp production stage. Logs are fed into the chipper, and the spinning knives chop them into smaller pieces. The ideal chip size for papermaking depends on the pulping process and desired paper quality. Generally, smaller chips offer greater surface area for chemical penetration during pulping, leading to higher pulp yields. However, overly small chips can create dust and hinder processing. These chips provide the raw material for pulp production. Pulping, the transformation of wood into paper pulp. Pulping is the heart of papermaking, where wood chips are transformed into a fibrous slurry called pulp. This pulp forms the very foundation of paper, impacting its strength, texture, and brightness. Chemical pulping. Chemical digestion. Wood chips are cooked in large digesters with various chemicals like sulfite or kraft, a combination of sodium hydroxide and sodium sulfide. This dissolves the lignin, the glue that binds cellulose fibers, freeing them for further processing. This process, called pulping, liberates the fibers, forming a thick slurry called pulp. Washing and screening. The pulp is washed to remove impurities and then screened to separate larger fiber bundles from finer ones. Different paper grades require different pulp compositions. Pulp bleaching. Brightening the pulp. For white paper, the pulp undergoes bleaching with chemicals like chlorine dioxide or hydrogen peroxide. This removes residual lignin and brightens the fibers, enhancing the paper's whiteness and printability. Why bleach pulp? Unbleached pulp, derived from wood, has a natural yellowish-brown color due to lignin, a complex polymer that binds cellulose fibers. Bleaching removes or modifies lignin, leading to a brighter and more appealing paper. Printability. Bleached paper has a smoother surface and higher brightness, allowing for better ink absorption and sharper printing results. Refining and additives. Refining. The pulp is further processed to adjust its properties like strength, flexibility, and water retention. This involves mechanical grinding or chemical treatments. High refining creates smooth, dense paper ideal for printing, while low refining produces fluffy, absorbent paper for tissue. Additives. Paper performance boosters. Various chemicals and materials are blended into the pulp to enhance specific paper properties. These include fillers, like calcium carbonate, to improve paper opacity and brightness. Wet strength agents, to enhance the paper's ability to withstand moisture. Sizing agents, to improve water resistance and prevent ink feathering. Dry strength agents, to increase paper strength and stiffness after drying. From pulp to sheet, the magical formation of paper. After the intricate processes of refining and adding crucial ingredients, the pulp finally reaches the stage of sheet formation. This critical step transforms the wet, fibrous slurry into the paper sheets we know and use. The refined and prepared pulp is pumped into a large, rectangular box called the head box. This crucial component acts as a maestro, evenly distributing the pulp across the width of the paper machine. Pressing. Squeezing out excess water. The wet web, still containing a significant amount of water, moves from the wire onto a series of press rollers. These rollers apply pressure, squeezing out excess water and further compacting the fibers. Drying. Transforming wet to dry. The pressed web continues its journey onto heated cylinders or through large dryers. These units evaporate the remaining water, transforming the wet web into a dry sheet of paper. Calendaring, smoothing the surface. In some cases, the dried paper may undergo calendaring. This process uses a series of smooth rollers to further smoothen the paper's surface and improve its printability and appearance. Finishing. Depending on the final product, the paper may be coated, sized, or embossed to achieve specific properties like water resistance, glossiness, or texture. Quality control and inspection. Throughout the process, the paper undergoes rigorous quality checks to ensure it meets the desired specifications for thickness, strength, opacity, and other parameters. Coating. Some papers, like photographic paper or glossy magazine paper, are coated with special materials to enhance specific properties. These coatings can improve brightness, water resistance, or ink absorption. Packaging and storage. Finished paper is packaged for transport and storage. Depending on the type of paper, it may be rolled, bundled, or stacked on pallets. Proper storage conditions, like controlled temperature and humidity, are crucial to maintain the paper's quality. Sizing. Sizing agents are applied to some papers to make them more resistant to liquids, preventing ink feathering or bleed-through. Cutting and sheeting. Paper webs are cut into specific sizes depending on the intended use, such as A4 sheets for printing or rolls for toilet paper or paper towels. Finally, the finished paper is cut, rolled, or packaged according to the intended use, be it for printing, writing, packaging, or other applications. Distribution and usage. Finally, the paper is distributed to various channels depending on its intended use. I hope this detailed explanation provides a comprehensive understanding of the papermaking process from wood in a factory. Thanks for watching. If you enjoyed this video, please give it a thumbs up and subscribe to my channel for more great content.